Thank you very much for MedicReS AI convention in Vienna, Austria, to give me a chance to present artificial intelligence in medicine. My presentation will include an abstract defining what the presentation is about, and the parts of the presentation will bring in what is artificial intelligence, genesis of artificial intelligence, AI in medical research, and ethics in artificial intelligence to state these definitions so we all have a common understanding and how the science is accelerating in artificial intelligence in medical research and ushering a new era in medicine. I just want to make sure my abstract is in line with the objectives. So since November 30, 2022, with the release of ChatGPT, a new frontier caught on fire with the unprecedented user acceptance of 100 million people. This is faster than any other product offering in the history of computing. But artificial intelligence has been around since 1950. The advancements in large language models, robust data sets, increase in computing power, reduction in training, cost for neural networks ushered a new era for innovation and efficiency in medicine. So this presentation synthesizes breakthroughs in radiology, pathology, ophthalmology, and cardiology with preference studies in their outcomes. And then AI is continuously evolving. So its integration into medical research promises to transform healthcare, accelerating discoveries, and ultimately improving patient outcome. What is artificial intelligence? As I mentioned in my abstract, it's been around for a long time. And to most scientists, the father of artificial intelligence goes back to Alan Turing, to a paper published in 1950, Computing Machinery and Intelligence. And Alan Turing basically asked this question: can machines think? And computer science and thinking is very related to philosophy. René Descartes, I think therefore I am, 17th century, all the way to Alan Turing, humans always wondered and questioned the thinking and what it meant for humans and beyond. So Alan Turing follows this question with a test called Turing test. A human interrogator attempts to distinguish between a human and a computer with a text response. The idea is, if the interrogator cannot distinguish which one is human, which one is a computer, they define that as artificial intelligence. But following 1950 and 1956, John McCarthy at the time at MIT, in a conference in Dartmouth in New Hampshire in the United States, also worked on artificial intelligence. And now he's a professor at Stanford University. And to him, it is the science and engineering of making intelligence machines. Intelligent more than the machines, since computers are on the software side, you could simulate any kind of machine. It's more on the software side that he's interested in. So understanding the human intelligence, but doesn't have to confine itself to methods that are biologically observable. And then a classical textbook, Stuart Russell and Peter Norvig, they define that to two sections: human approach, which is systems that think like humans, and systems that act like humans. And the ideal approach, systems that think rationally and systems that act rationally. Alan Turing test falls into the category of systems that think like humans. So what are the types of artificial intelligence? There's weak artificial intelligence versus strong artificial intelligence. So what we mean by weak artificial intelligence is also called narrow artificial intelligence. They are defined to very specific tasks. And most of the examples in life, what you hear about today, are examples of weak AI. Siri, Alexa, autonomous vehicles, speech to text, those are examples of weak AI. And the strong AI, as of right now, there are no examples of strong AI. Falls into two categories: artificial general intelligence and artificial superintelligence. Artificial general intelligence is theoretical AI, and basically machines intelligence is equal to human intelligence. And artificial superintelligence exceeds the human intelligence and its abilities. Uh, and furthermore, there are subfields of artificial intelligence, machine learning versus deep learning. Deep learning is also a subcategory of machine learning. So in machine learning, you need to have human intervention to learn. It depends on humans. Humans define the hierarchy of the inputs. They define the distinguishing features, and then they require more data, structured data to learn. Deep learning, subfield of machine learning, is made of neural networks, just like human brain. What we mean by deep is minimum 3 layers, including input layer and output layer in the neural networks. And then it automates, instead of human interventions, it automates the feature extraction, but there's still minimal human intervention is required for the feature extraction, and then requires very large, robust data sets enablement. So if you look at ChatGPT, probably the data set that required to train the engine, it cost about $100 million to be able to do that. Generative models goes further. So there's not that much human intervention. It ingests unstructured data, raw such as images. And then based on that data, they're able to come up with statistical probable outputs when prompted. They look at their data encoded in a simplified version, but they are able to create a new version of the data, but not identical to original data. This existed for a long period of time in statistics to analyze numbers. However, deep learning extends this models into complex data types, images, speech, and among others, it's unstructured data types. And all of this started in 2013 with a class of models called variational autoencoders, and generated realistic images and speeches. This was the inflecting point. And ChatGPT is developed on top of variational autoencoders since 2013 with the advancements. AI in medical research. So what fuels AI in medicine? So right now, from paperwork to transitioning into electronic medical records, digitize the healthcare data. Common use of fitness trackers, remote healthcare devices, decreasing cost of computing and decreasing cost in training with robust large data sets, enabling more and more AI use in medicine. So what are the promising areas of medicine utilizing artificial intelligence currently? So I categorized specialties in medicine with giving examples of some studies proving that AI is in the right direction to assist medicine and medical staff. So diagnostic radiology. In this example, there's an automation, image segmentation, lesion detection, measurement, labeling, and comparison with historical images. And the study was done by Lakhani and Sundaram in 2017 for the purposes of testing, diagnosing tuberculosis. And they used chest X-rays, and they used images of about 150 cases. And the result was 96% accuracy, and which is about the same as a radiologist, a human radiologist. On the pathology side, so these are mostly like imaging, recognizing images, and in pathology as well. Cool in 2007, in this time period, they compared the traditional computer-aided detection systems that is used for cancer lesions. Compare that to the convolutional neural network AI product. How do they detect breast cancers on 45,000 images? And the convolutional neural network outperformed the traditional way of detecting breast cancer. And AI is also in ophthalmology. So in the United States, Food and Drug Administration approved an AI-based device to detect diabetic retinopathy in 2018. And also, AI can help assist to diagnose and grade cataract in pediatric patients. And that was done in 2017 by Liu. In cardiology, there's a larger study, cardiovascular risk prediction by correlating complex interactions between risk factors by Wang in 2017. So they had a sample size of 295,000 patients. They correlated their heart attack rates with their medical records. And then they used machine learning algorithms, neural networks accurately predicted 7.6% more events than the American College of Cardiology and American Heart Association method, with 1.6 fewer false alarms, fish in 2017. As you can see, AI can assist the cardiologists in helping reducing fatalities in cardiovascular events. And furthermore, there are more areas coming into focus with AI in emerging gene editing and drug discovery. So about $1 billion spent to discover a drug, and most of the trials and errors is due to molecular discoveries. So AI's pattern recognitions, ability to analyze enormous amount of data in a short period of time will help drug discoveries in a shorter period of time, safety and efficacy, and then make it more available on an individual basis, catering to special needs of the patients. With this comes the question of ethics, which is a continuous debate, a big concern, both proponents and opponents of AI. So I want to summarize what's important in ethics, at least from my perspective, in artificial intelligence, right? So basically, it's the difference between right and wrong. Since the inception of time, this is a saga that people go through, constantly identifying what is right and what is wrong. Same thing for artificial intelligence. My objective is augment rather than replace humans. And then intellectual property, data belongs to the creator. And you need to be open about and clear about the origins of data, because there is bias, conscious or unconscious bias in that data. And the trainer and algorithms needs to be explainable and traceable. Medicine and medical records require a lot of privacy and security. So all the work in AI, specifically in medicine, needs to be thinking about the ethics while we're doing all this research to advance medicine. And with that, I conclude my presentation, and then I look forward to further discussions in the convention and learn from my peers, colleagues, and attendees. And thank you for your time and attention.